consultancy called Cognitect. Cognitect, we work with various clients, and the CTO of Cognitect is Rich Hickey, who created the Clojure programming language, which is a modestly popular functional programming language for the Java virtual machine. At Cognitect, our philosophy is that there's a lot of accidental complexity in modern software development, and that one way to address that issue is to sort of embrace simplicity. We sort of adopt a viewpoint which I'll dig into a little bit more detail here, but there's this paper called Out of the Tarpit, which we'll talk about in a second. But this idea that people talk about simplicity, they come up with all these ideas, and we have a very narrow definition. Our definition is that in order to build simpler systems, you really have to embrace more management over state. You can do this through immutability, immutable data structures. So Clojure is a programming language which sort of innovated. It took like this sort of theory of persistent data structures and came up with ones that were significantly more efficient based off of research by Phil Bagwell. A whole programming language designed around that. That eventually got, there's a compiler for Clojure to JavaScript called ClojureScript. I'm the lead developer of ClojureScript. So all the persistent data structures that are present in Clojure were ported to ClojureScript, and they work very well on modern JavaScript virtual machines because most of the innovation techniques around the JVM made their way into JS engines as well. And then we have something which people probably haven't heard that much outside of the Clojure community except in passing, which is Datomic. There's a ton of stuff to talk about around Datomic, but I don't have 8 hours. So I'm going to have to be very narrow and very specific about that. But basically, we build systems where basically each major component of our stack embraces this sort of immutable approach to software. And we believe that it allows us to focus on the hard problems, right? Every domain that you have has hard problems. But at least by adopting this approach to software, the typical issues that you run into, we can at least mitigate those. So this is sort of like a system level talk. I mean, again, I don't have time to dig into all the things around Datomic. Datomic is very cool technology. But I'm mostly interested in Datomic with respect to its impact on building practical systems. Right? So Datomic is a very practical database. It's used at companies like Netflix, Facebook. Big companies use it. It's a practical component in whatever application you're building. And it's very much focused on being practical. So this is a sort of, again, a system talk. I'm not going to talk that much about programming languages. It's really about when you're building this typical sort of distributed application where you have clients. The clients run JavaScript, whether that's native, and that's Android or iOS, or it's a web browser. You have to build some server component in some whatever language you prefer. And then you have a database, right? The sort of three critical parts of any system. And then, of course, you have all your other services. But whatever. These three are extremely important and very typical. So this is an image of a tar pit. I believe the original artist is Charles Wright. This image is, I think, pretty well known among software engineers because it's on the cover of Fred Book's essays, The Mythical Man Month. The tar pit it's a really great analogy for modern software development because the tar pit, you have some mammal gets trapped in the tar pit and they're there and they're starving and they're stuck there for a week, and then a predator is like, oh, this is going to be easy. I'm just going to jump in there and eat this mammoth. It's stuck. Then it gets stuck, and then the buzzards are there, and they're like, ooh, I can eat the mammoth and the dying saber-toothed tiger, and they get stuck. It's a big mess, right? So but it's a good analogy for software in the sense that often when you make a decision, it's hard to see all the other things that are going to get entrapped by that particular decision. Again, this book, I'm not going to talk that much about it. What is interesting to me, though, is this paper, which is not a response to the Mythical Man Month, but Fred Brooks' paper, No Silver Bullet, where he's talking about there's no easy answer to the quote-unquote software crisis. But Ben Mosely and Peter Marks, they're Haskell programmers. They've spoken before here at CodeMesh. And they published a paper about 11 years ago in which their thesis was that what Fred Brooks says is essential complexity isn't really essential complexity, that a good amount in their experience, again, they're Haskell programmers, even in their Haskell systems, a lot of the complexity of the systems they're building arise from sort of an undisciplined approach to state. And so they outline this thing called, before I get into what the thing is called, so they make a really great point. Again, these are people of the sort of typed functional discipline. And they make this amazing point. This quote is actually often incorrectly attributed to Rich Hickey, because Rich Hickey did this talk called Simple Made Easy, where he was like, what happens when your programs fail? Well, that means whatever issue you had passed all your tests and it passed whatever type system you have in place. And people were like, you're talking badly about type, test-driven development. You're talking badly about types. But actually, he was just rephrasing something that's in this paper, which is that given the choice between testing and reasoning, and by reasoning they mean whether that's reasoning power given to you by a programming language or the compiler or whatever, that the most important property in any system that you're going to build is simplicity. It's really their quote, that simplicity is the only thing that's really going to pay dividends as you have to move from I'm building a new system to the long tail of having to maintain that system. And again, their thesis is that Fred Brooks's claim that software is inherently complex is not true. Of course, there's complexity native to the domain, but a lot of the complexity that gets introduced into software systems is of our own construction. In fact, most of this paper, they're sort of apologizing for being quite boring, since most of the advice they're giving you has been known for at least 3 or 4 decades. Okay, so they come up with this term, FRP. You may have heard of FRP before, but you're probably thinking functional reactive programming, which is pretty hot these days with languages like Elm and other people adopting that technique in UI work with languages like JavaScript. But they're not talking about functional reactive programming. They're talking about functional relational programming. And what I really like about this paper is not particularly dogmatic with how one might go about doing this. In fact, it becomes very clear upon reading this paper. If you haven't read it, I highly recommend it. Read it out of the Tarpit, but that it can be adopted in any system. It requires no particular choice of any particular technology. By functional, they don't mean you have to use a functional programming language. You can do this with Java. You can do this with JavaScript. But to basically take sort of a functional mindset and to limit the amount of state. And then you might say, well, is that really practical? And I would say, well, it may not necessarily be, but I think there is kind of a big change in the mainstream, and we'll talk about this specifically around React, in which that actually a lot of JavaScript programmers are actually now very functional, whether they're aware of it or not. So I think now is a good time for some of these ideas to gain traction. Relational, this is their point in which that when you build a system, you sort of define your essential state and your sort of essential logic. And they point out that one of the hugest drivers of complexity besides state is definitely like the biggest, but it's that we often don't take a declarative enough approach to solving our problem. And specifically, they talk about, they have this nice diagram. On one side on the left, you have accidental state and control, which is basically all that stuff is about performance and maybe some convenience and caching and all that sort of stuff. But this middle area is what you want to do. Essential state, you want to define that, essential logic, and you really want, you notice, and most of this is relational. You want as much of the system to be sort of oriented around queries and not around writing custom code. And then they have this thing called other, which we'll talk about. They actually, in this paper, they didn't have a particularly in-depth answer, which is, well, where does the state come from? And this is going to come from users. It's going to come from interactions, right? UIs is definitely a big place where the data comes from. But so they paint this really nice picture. It's they kind of say this is a way out. And they talk about in the mainstream, it's really quite different. So people say, oh, we're doing TDD, or we're using Java, or we're using we're building a component-like system, or all this engineering stuff, right? We have all these interfaces, all these classes. And really, in the end, none of that stuff really matters, because what's actually being done in the mainstream is what we at Cognitech affectionately call PLOP. PLOP is a very technical term. It stands for place-oriented programming, right? So it doesn't matter how much abstraction you create. If you build a stateful system, your ability to reason about that is greatly diminished. This is why people sit around in debuggers all day, right? Because they have a stateful system, but they can't actually reason about it at any sort of higher level than being in a debugger and trying to unravel how their program ended up in a particular state. This is another very technical diagram. This diagram could be used to represent your front-end component, your back-end component, or any other part of your system, right? So who cares what these things are? Generally in the mainstream, again, it does not matter where you can take this diagram, put it anywhere, and it's going to look like this. You have some component A in some element of your system, and it's stateful. And so when something goes wrong, where did it go wrong? Did it go wrong, in this first part of your system? Did it go wrong in the second part of your system? Did it go wrong in some third part of your system? And the thing is, when the problem occurs, because your system is stateful, you have no idea. You have no idea. And then there's a long week of just being like trying to reduce it down to a minimal case, to remove whatever assumptions you have about the behavior system, because again, you have something that you can't actually reason about, because state is not linear, right? Every time you add a stateful component, it's at least extending the state space in an exponential way. So something else that they talk about, which I think is extremely important, but these are sort of side notes to the state thing, but they are related to the points I want to make about Datomic. One is subjectivity. I think everybody knows the power of abstraction, but I think something that people don't really understand about abstraction is subjective, right? You're in Java, or you're making an interface, or you're in Haskell, you make a type class. Well, that's just your idea. That's your choice. And in fact, you've now imposed something to anybody that wants to consume whatever choice that you made. And this, I think, is extremely difficult. I would say it's almost like how to get good at designing abstractions. That's just simply like decades of effort. And you've just been doing it so long where you have at least some taste, and likely you know how easy it is to get it wrong. But this does affect the design of a system or an architecture, right? So one of the biggest issues is that you have clients, right? You're building some sort of system, you have a client, and then the backend people design some response. And there's a bunch of problems with this, right? Because you've designed a typical response. The client doesn't really have any query power. All they can say is, I want this many pages, I want this sorting. That's all they can say. So what you've then delivered to them is the subjectivity of your decisions, right? They are now stuck to whatever you thought was a reasonable thing, but it's not possible for it to be reasonable because they're building a UI, and there's no way that you could have made any choices that were correct for whatever the UI needs. The likelihood of that is extremely low. So then they have to take on the sort of accidental complexity of the fact that your response does not match what they need. The other thing that you encounter in these sorts of systems, which is everybody is building, I can't remember the last time I didn't work on a project where people were doing this, is that now the client has basically, there's path dependence, right? The relationships are hard-coded. The front end now has path dependence, right? They have to know the structure of the thing. And it's because of this problem that whether you're when you go to conferences and you listen to what people do, they now say things that you're no longer allowed to do. Versioning, really it's over. People don't even version APIs anymore. The rules are you can never change a name. You cannot change the structure. You can't delete names. You can only add new information, right? Because that's the only thing that won't break the universe. Once you've made an API and you have clients, you have no idea who's consuming it, whether that's internal to your company or not. You have no idea who's consuming it, and you have delivered something which is path dependent, right? And you can make no choices that won't break somebody. And so this I think people do not take seriously enough, how subjective API decisions are. And there's this amazing thing, and that's what they're talking about in this paper. Relational algebra gets you out of path dependence, right? If you deliver query power, some restricted set of query power, now people can write relations, and they are no longer tied to whatever arbitrary decisions you made, which are most definitely not the right decisions. The other thing that they point out, which is I think yet another thing, but that's data hiding. And data hiding for me is yet another typical sort of abstraction thing that people like to do that really delivers zero value. But we can argue about that later at the party. Okay, so I've been doing front-end work for a very long time, and of course I started off with sort of the object-oriented persuasion. I enjoyed it. You know, you're young, you do this a lot, and you're like, ah, this is fun, this is fun, this is fun. And then after about 10 years, like, this sucks. Because you realize that you read these about these approaches, and everybody says it's the right way. You buy the books, you read the books, you build the thing, and then you're like, well, this doesn't actually work that well. It's just a lot of effort. There doesn't seem to me that much deeper thinking around this stuff. You know, it's all sort of, I don't know, it all feels pretty ad hoc. And so I was feeling pretty bummed out about UI programming after doing it for about 10 years. And then I was like, you know, we're never going to get out of this Tarpit. It's just really, this is the state of the art's pretty low, and it's not going anywhere. And fortunately, something has happened, which is quite surprising to me, especially having followed the mainstream for a long time, which was that at Facebook, a single developer named Jordan Walk was building a traditional MVC-style application at Facebook, and he decided, this sucks, I'm going to do this crazy thing where I make a virtual DOM, and I'm going to make it so that I have a mostly functional API. We're going to present a nice JavaScript object-oriented layer, but the whole thing is basically going to be functional. He was an OCaml developer, and he was given 6 months to try this, and it turned out the thing that he built was at least at parity in terms of performance, and they built a thing, and then they announced it. And this is actually, it wasn't being used that much at Facebook. Facebook had a sort of open source initiative, and they talked about it, and you know, a small number of teams. And then actually really React exploded outside of Facebook. React, you know, really it had a rough start because it had something that programmers hate, which is like XML literals. Nobody likes XML literals, and Facebook launched React with that sort of thing as a sort of distraction. Anyways, my friend said, hey, actually it's cooler than it seems, you should check it out. And what I discovered was that for the first time, you know, I've been doing JavaScript professionally since 2005. For the very first time, somebody had written an API which was functional, meaning that it could be adapted trivially to a functional programming language. I'd been developing Clojure script, leading development for about 2 years. And basically everything that we integrated with was stateful, just the typical stuff. So it was really not much of no benefit, right? You'd be using Clojure script, you have all these immutable data structures, but then in the end you have to integrate with Angular or Ember or whatever, these things that are mutable. So what benefits were you actually getting? You were just writing JavaScript with a functional programming language, no benefit. But React did something significantly different, which was that you could drive React with immutable data structures. You could have some sort of tiny bit of state, which is the root. You could sort of treat your entire application state as a database on the client, right? This single global store. You put everything there, and then basically the entire UI can be a function of what's in the global store, and you can just render it. Of course, you do a couple tricks to make it be for optimization, but that's all the accidental stuff that Ben Mosely and Peter Marks was talking about. You can, like, React lets you go fully functional. The semantics are very functional, and you have just a tiny bit of state. And the results were pretty astounding. In less than 2 weeks, or exactly 2 weeks, I was like, well, now that I can build a React UI from Clojure script that's mostly functional, I was like, I'm just being driven by functional data structures. I wonder how long it would take me to do like a time-traveling UI, which is, in an object-oriented world, it's really annoying. You basically, you have to reify all your commands, you have to like keep that history, and it's annoying. I mean, it's definitely more than 10 lines of code. And I was able to write this in 10 lines of code. Because the entire state is an immutable data structure, I could just keep a list of the states of the app, and you could go forwards and backwards. Other people were like, oh, well, you could do tree undo, all that stuff, right? That stuff is possible, again, because the UI is just a function of whatever the current state of the application is. And I did these 2 posts. They were the most popular posts I've ever written, and I like to think they helped kick off at least excitement about React outside of functional programmers. Anyways, so back to my point. So the point about React is that there's now a very large segment of the mainstream which understands functional programming, whether they know it or not, right? React, you design a thing, you basically have a view, you have pure components, you pass props. Props is supposed to be just a value, right? Components, UI components now just take a value, and there's a direct mapping from the value you pass in to the thing you see on the screen. So they already know this. React only has one official API for doing something stateful, And people know to restrict that only to sort of the root of the application or important roots. It's called set state. So React fundamentally encourages UI programmers to be much more restrictive about state. Other important things that it does is that it makes event handlers be mostly stateless, right? So if anybody had been doing, whether it's like JavaFX or Java Swing or web stuff, the fact that you have to add event handlers, that's a stateful operation, right? You have to add and remove listeners, right? Even the most basic thing, in order to get anything done in the UI, requires stateful operations. But the way that React works, event listeners aren't stateful. You don't have to manage their lifetimes, which is extremely awesome. So can we take this idea? So my question is, with this talk is, what happens when we take this very nice disciplined thing and say, why don't we just do this everywhere? At Cognitect, we've been doing this now for probably with clients for at least actively for 2.5, maybe 3 years. These are the types of systems that we build for clients. So instead of doing this thing where there's a Tarpit of your database, which is some mutable variable in the sky, some programming language is immutable on the server, and some mutable mess on the client, we replace these things, right? So with React, you can just be like, actually, we want to simplify the client. We don't want to have to. We want testing to be easier, reasoning to be easier. We just want something more maintainable. You can do that now. You can choose to use Haskell or OCaml or Erlang or whatever, and you adopt that on the back end. And our experience is that prior to Datomic is that this is all nice and it does remove a lot of problems, but in the end you still have this problem of the DB being a giant mutable thing. And when something goes wrong, you're there. It's even worse than trying to debug something in the client because you don't have a debugger. It's all distributed, and you're like, what's going on? And then hours later, maybe you figure it out, maybe not. So Datomic is just a different approach. Again, Datomic is not, I would say, it's not like, we'll get into its properties, but really our goal with using these three technologies is that, again, clients are building sort of typical stuff. Like something in the past they would have used, PHP and JavaScript and MySQL. So all we want to do is replace those three things with something that's, again, embraces immutability. And that's what we do at Cognitect. But Datomic is actually, again, it's now language agnostic. There's a client protocol. I'm only going to talk about that briefly. But you could do this. You could actually build a functional relational architecture now with just Node.js. And you could use the various functional libraries there. And you could use React. And you could have the same thing that they're talking about in the Tarpit. So when they wrote out of the Tarpit, they said there's no practical off-the-shelf technologies to do this. But again, in 2017, there's a massive number of immutable data structure libraries and functional libraries for JavaScript. React, it's mostly functional in the front end. It gets you to many different interesting clients. And then Datomic just replaces this notion of having a mutable store on the back end. OK, so let's talk about Datomic real quick. What are the properties of Datomic? Again, this is going to be very truncated. I'll list some talks to see at the end. It's ACID, it's relational. If you're interested in write scale, then Datomic is not what you want to use. It's not what it's for. If you're OK with the sort of ballpark performance of MySQL or Postgres, you're fine. It's immutable, so this is what we're adding. This is what we're bringing to the table, and we'll see that. It uses data log queries and rules, which are nice. This is just kind of an affordance. It's just an ergonomic thing. After having used Datomic for a while, data log queries and rules are pretty cool. But I'm not going to have time to dig into that. And it's now programming language agnostic. So about 2 years ago, I started working on a JavaScript client, and we also have the beginnings of a Java client. So it's just over HTTPS. We use Transit, which is a transport format that we use. And it's possible to make very idiomatic bindings to Datomic. I'm going to show it to you in Clojure, because that's what I actually have fully working. But there's little snippets of JavaScript, so you could get a sense of what it would look like in an object-oriented programming language. All right, a whirlwind tour. So again, the thing that I want to point out here is I can't dig into every feature. Datomic has a lot of features. I'm mostly interested in describing what are the ergonomics if you're building a system? Get a sense of what they're like. Okay, so here I have a Clojure REPL fired up. And I'm just going to go through just some high level. Is this big enough? Maybe the lights? Maybe I should. Is it possible to dim the lights? Or maybe I should just switch the invert. Yeah. 1 second. It's okay. Yeah. Okay. Theme. Default. Okay. There we go. All right. That was easy. Okay. So I have a REPL here. So I'm going to just demo some quick things. I don't have time to dig into every feature of Datomic, but just some high-level stuff that affects what your experience is like when you're building an app. So I'm going to make a DB. I'm going to create it. I'm going to connect to it. I'm going to set up a schema. I'm going to transact some initial data. And the thing I'm going to do here is I'm going to record the demo at the start. I'm just going to record the time. And then at the end, I'll run a query on the database, the value of the database from before I start, or from before I change the database. Okay, so that's the start time. And what does Datomic look like? Datomic, it's like data log queries. Above, I have what it would look like in JavaScript. You would have something that looks a lot like LINQ or something, if you're familiar with LINQ, C#. But in Clojure, it looks like data log syntax. Here we can say, we want to find all entities where the person's last name is this logic variable, and that's what we're looking for. So Datomic is basically it's a bit like a triple store. You have entities, they have attributes, they have values, and Datomic adds this fourth hidden thing, which is what was the time, the logical time that fact was added. Facts are triples. So let's do this, and it returns a set of results, which is just those last names. I can ask, you can just make this a little bit more complicated. So here I have two clauses. I can say, find the first name and the last name, returns that. Up here you can see that it would look, like this fluent DSL for JavaScript. You can, of course, parameterize, but I'm not going to get into all that. But here I can say, find the person whose first name is Kovas. And it's just going to return the entity ID. Entity ID is just like, DB ID. It's just a 64-bit long. And here I can say, there's negation. Here I can say, find the person's first name as long as their last name is not Smith. And you have disjunction, the typical stuff that you're used to. It's all there. You can do fancier queries. I can say, find the person named David Nolen, find the organization they belong to, find the organization name, and then given that organization, also find all people that are also in that organization. And this shows kind of the power of using data log. We don't have to talk about this typical SQL madness around inner joins, outer joins. So what's really nice, especially for doing UI development, is that it's very natural to write graph queries. If you've been following UI development, one sort of trend right now is GraphQL, as well as Netflix has a thing called Falcor, in which clients basically get to specify the graph of relationships they want to pull. And by doing this, they're eliminating this API problem that I talked about, in which that now client, you don't hard code some assumptions about what the client wants. The client gets a nice, very highly simplified query language, which allows them to express the graph, and then they can simply pull that graph out of the DB and then immediately render it. They don't have to jump through any additional transformation steps. Right? You're just giving clients, you're preventing them from taking on the accidental complexity or whatever hard-coded choices you would have made in the previous world. So Datomic is a good fit. It's a very good fit for this sort of GraphQL Falcor style front-end development. Here I can go, so related to that, if you know GraphQL or Falcor, so here I can say, given this entity, which is just this number, find the entity whose last name is Bogota, and then I can pull. So this gives you a sense of how easy it would be to integrate with something like GraphQL or Falcor. I can say, give me all the properties of that entity. So actually recursively pull them in. So something that if you're doing like MySQL, a lot of the move towards document style things or key value stores or JSON databases is that it's unnatural for clients to get flat lists of stuff. You actually want to pull a tree structure. You want structured data because that's what you're going to present. The UI is going to present structured data. So it's more natural to present structured data to clients. And so you get the sense of in Datomic that it's like okay, it's just a relational database. It's that we get to have all the convenience that you had with the document store, which is that it's trivial for you to get structured data out of the database. And this is, there's no ORM, there's no ORM, there's just data. There's no unnecessary abstraction. It's just the data that you want. I can say, I only want the first name. So here it's a vector. You can say, instead of pulling all the properties, this is star, give me everything, I can say, I only want a dictionary with just the first name in it. Down here I can say, I want the first name, the last name, the address, and when I get the address, I only want the city. This is absolutely typical stuff that you need to do when you're building UIs. Except instead of getting this massive crazy response and not getting what I actually need, I can simply say I only need to render these properties. Just give me those properties in the layout that I need them to be in. So I'm going to wrap this up. So here I'm going to add some new data to the database. I'm going to transact a new email address for my friend Kovas. Here I can say, given Kovas, give me all the data for the email entity, all the email entities he has, and I get all of his email addresses. But I recorded the start time of the talk or the demo, and here I can say, give me the database, and I want the database value at the start time. Right? So the big value proposition is that Datomic is no longer this mutable thing. It's no longer this mutable variable in the sky. Right? I can say, I know when I want this query, return me the database as a value. Like you get to treat, just like 1, the number 1 is a value in your program. Now my database is a value. I want the value of the database when I started doing this demo. So I get a reference to that, and I can say, yeah, of course, I had not added that email to the DB when I started the talk. And so customers love this. So people that love to do auditing or sort of like more powerful queries about what happened. I mean, like you can think of all these crazy business applications, but even just debugging. Like why does it not work today, but it worked on yesterday's data? And that's, you made some code change. What's different? And now the database is not in your way. You can be, okay, let's go back and Git, let's run the query, or let's go up and Git, let's use yesterday's database, and you have more tools for figuring out what went wrong in your system. Okay, so hopefully that makes some sense. Again, that had to be a whirlwind tour. Maybe I have some time for some questions. If you're more curious about the philosophy around this stuff, I definitely say watch Simple Made Easy is very well known. But I think ones that are actually even more important to watch are Language of the System by Rich Hickey, Databases of Value if you're curious about like all the ideas around Datomic. If you're curious about using Datomic, there's also some, which is another reason why I didn't talk that much about the specifics about how Datomic works, is because that's changing. So a few months ago, not even a few months ago, last month at the Conj, they announced that Datomic is available on the AWS Marketplace. So that just means that so whenever you choose a DB, one of the biggest problems is like, it sounds all fine and good, but I don't want, how hard is it going to be to operate the thing, to make it operational? And so that's a new thing. So we provide a version of Datomic which is basically a button click, and then it's completely integrated with all the scaling resources on AWS, meaning auto-scaling, DynamoDB can now be dynamically provisioned, and this version of Datomic really, literally, you push the button, and then you can just start talking to it, which is pretty cool, and I think lowers the barrier to entry for actually wanting to use this for something. So that's all I had, and I think I have a few moments for questions, but thank you.
So we have some time for questions.
So when you saved off the time and then you got a previous version of the database prior to that time, that seemed a little scary because you were using Java util date to get like the current notion of time, not like the database's notion of time or anything like that. So you have to ask questions about drift and things like that. Is there a way to get the database notion of time?
You don't have to use, so it's just convenience for the demo. Datomic records both you can get a value of a database based off, of course, time, which is, you should be careful. But you also have logical time. Every transaction says this is the basis of the DB. You can use the basis to get the DB value you want. But also every transaction produces a squid, like a universal identifier, and you can use that as well. So there are multiple ways to get the value of the database that you need.
Great talk, thank you. So I realized you were talking about functional relational, not functional reactive, but I think there's a really interesting crossover area between the two, and I'd be interested in your thoughts about that. So specifically, typically with relational queries, you send off your queries, you get back a result, but if the underlying data changes, you don't hear an update afterwards. The only thing you could do is poll to see if the result has changed.
Yes.
Whereas with things like the reactive programming style, actually the data flow gets changed the other way so that changes in the underlying data can be pushed all the way through to the UI. Do you have thoughts on that?
So Datomic has a transaction queue, which you can subscribe to. So it emits, every time that there's a transaction, it emits an event, and people built systems that specifically read that and push data. So that was one of the original design choices, that Datomic has a reactive sort of part to it.
Yep.
So the people, this is a common question. So Datomic is not an open source database. It's a proprietary database. You can use it for free. We have something called Datomic Starter, which is basically effectively, I think it's pretty, the licensing is really lax. I mean, I think you can have, I can't remember, but I feel like the number of peers you can have is pretty significant. But yeah, you can use it, and there's no support, but you can use it. And that's actually, almost everybody starts that way, and people often build out their system over a year and a half, maybe 2 years, and only when they hit some sort of issue do they ever come bothering us about anything.
So if I understand, Datomic is a database that run on the client.
No.
Side?
So it's just like MySQL, right?
Yeah.
Or Postgres. You operationalize it somewhere else.
Okay.
Yeah. So it's not about. So just to clarify, the reason I was talking about clients is because it's my belief that all the design choices that you make are of one piece, right? So often when you make a choice about your API or choice of your database, those decisions affect everybody. And my point is really that an ideal architecture, at least to me, is that clients can get what they want. They can describe what they want. You have a database that makes that easy to implement, because that could be challenging to implement yourself. And then you have a language in the back end which allows you to basically eliminate state. And Datomic is one answer to that problem. There's, of course, other ways to achieve what Datomic does. Clojure is one way to get to that, the back end to be less stateful. And then clients, you can do whatever you want there, but my point is that you really want clients to be able to request what they need, so they're not writing all this unnecessary code just to convert that response into something they can present.
So you, sorry. So you talked briefly about debugging in the database, and debugging in respect to databases is sometimes having to deal with buggy code, client code that only triggers a bug when a certain value is in the database. So you would probably need a copy of the development of the production database as a developer, but that's not always possible because of like privacy rules and stuff like that. So is there a way to rewrite history throughout the layers of?
Rewrite the history.
Say,
I mean, the answer is just...
Datomic is based upon layers and layers and layers of values, I thought, and you would have to change all the values throughout the historical additions of values.
I don't really understand how rewriting the history has anything to do with debugging.
No, I want to remove, say, all of the credit card entries that ever
So
were
for,
made.
so for legal reasons, you must
Yeah.
support deletion of data, right? So there's
Not really deletion, but just replacement with other values, that is.
so I don't, so your question is, there's a lot of ways to answer that. Okay, first off, so can you delete stuff? So legally, it's a requirement. So we have a thing called excision, which you shouldn't use unless you're doing, you're satisfying some legal thing. Another question I think you're trying to ask is, can you add data and like test it with that? So Datomic actually supports something called withDB. So you might want to do some sort of testing query, which means you want to take some data set that you have and you want to add some new facts without actually committing the database and see what those results might be. So people use that for testing. You have some database and you have additional information you don't want to commit, but you want it to affect the query. That's also possible. But editing the database, that's just like not in the, that doesn't seem to be really in line with what the database is trying to do here, right?
We can do one more. You had one? Yeah.
This sounds very interesting as a database for event sourcing. Do you have experience with this?
People have used it for that. I haven't personally spent that much time doing that. A lot of the applications that we build are it's just some complicated system they need that looks more or less like, you know, we have to add information. There's some big schema, and there's a UI component, but we haven't done anything specifically around event sourcing. I haven't personally. Other people have.
Right scale is a problem if you do event sourcing with it. Because like Datomic explicitly doesn't, like your scale of writes has to be small to use Datomic, which is sort of a design choice, right?
Yeah. So one tiny thing about Datomic is that it's a single writer model, right? So the way that it works, you can have many readers because anybody can read it because it's immutable. Anybody can read, but all writers are blocked. There's one machine that's going to be the transactor. I mean, anything that I might say is also subject to change, but that's how it works today.
Let's thank David.